last week, if you had, what other fraction do you want to use? We had multiplication. What could you do with this? What could you do if you're multiplying two fractions? Yes. One, we can go across the top and across the bottom. 3 over 5, 12 over 40. Is that good? What can you do with it then? How? Six doesn't go into 40. But why start so big? What's the more obvious one? Okay, or I was even thinking 2, because they're both even. Why think harder than I have to? Right? You can do it by 2s. I don't care. And go, oh, well, they're even again, so you can do it again. We get to 10. Doing it by 4, you only have to do it once, but you notice you had to sit and think about it. Taking the 2s out was really turned out to be just as fast, didn't it? So do you have to, that whole thing, you have to take out the LCD? No, you don't. I don't care as long as you get there. Now, does 3/10 make sense though? Why? Okay, that won't reduce, but as an answer, does 3/10 make sense? Why? This is what I want you to get in the habit of doing. 4/5. That's not even one whole thing, is it? 3/8 is less than a half. True? If I take less than a half of something that was not even full, I'm going to have a pretty small fraction, right? That makes sense? Is that a pretty small fraction? That's what I mean by does it make sense? It's not checking your work. If I want you to check your work, I tell you to check your work. I just want you to get in the habit of taking a look at that and go, am I even in the right ballpark? Because that'll tell you if you've had a moment. What would be another option for this? What was option 2 here? And again, you don't have to know all the options. You pick the one you like. But you might find one you like better. What else could you do with this? Cross multiplying? Okay, if you tried that, you would get what? 3 times 5 and 4 times 8, 15 over 32. What are you going to do with those? Exactly the point. Well, make a fraction. Which one goes on top? Well, would 32 over 15 make sense? 4/5 times 3/8 is a number that's bigger than 2. Does that make sense? No. How about then 15 over 32? That's a little less than half. Well, I already started out with a little less than half, and I'm taking only part of that. So does that make sense? The answer should be smaller yet than that. And the cat, what you just did was you went back to the rules. Something that, remember when you memorize a rule, they're asking you to know 4 things, not 1. The rule, when you can use it, when you can't use it, what are the exceptions? The cross multiplying help. What I remember about cross multiplying is you gotta have a bridge to cross, i.e. an equal sign. When you have an equal sign, there's no bridge, how do you go across? Yeah. Well, that didn't work. But what does work? What else can we do here? Anybody remember canceling? Canceling is the same thing as we did here, only we're doing it up front. 5 over 4 won't reduce, but what about 4 and 8? Notice 4 and 8 were both one stop and one stop. Is there something that goes into 4 that also goes into 8? 4 does. We're going to divide both of them by 4. So instead of using the 4, I'm going to use 1. Instead of the 8, I'm going to use 2. What about 3 and 5? So anything goes into 3 goes into 5. Now if I multiply across the top and across the bottom, I get the same answer. The nice thing about canceling is you're using smaller numbers. The danger in it is sometimes people pick and only, like say, pick 2 here instead of 4, and then figure I don't have to reduce my fraction, my answer. If you only use 2 instead of 4, let's see, this would become 2 over 5 times 3 over 4 is 6 over 20. You don't have to use the biggest, but you got to be aware, does this reduce? Yeah. But the nice thing about canceling is it does make the number smaller, so it's a lot quicker. And it doesn't, and if you don't do it quite, usually any reducing or simplifying is pretty minimal. The downside to canceling is